There are many different show commands that we can utilize to verify the interfaces on our routers. Show IP interface brief is one of them. The keyword brief, meaning that we are going to get very limited information about that interface. But here's what it's going to give us. It's going to give us the ability to know what interfaces are available on the device, if there's any IP addresses assigned to those interfaces, and whether we're up at layer 1 and layer 2 of the OSI model. We have show protocols that's available to us as well. And we're going to be able to see brief details about a particular interface with show protocols. We're going to be able to analyze the specific interface if we want to by typing in the slot and the interface number. Show interfaces is going to allow us to verify details about the interfaces. So for example, if I type in just show interfaces, every single interface in the router and the details pertaining to them will be displayed. So if I'd like to minimize the amount of information that's displayed, then we can type in show interfaces and then specify the specific interface. So type in show interfaces, gigabit Ethernet 0/0, and that's going to give me just the details about gigabit Ethernet 0/0. But regardless of what output I'm looking at, one of my major concerns here is with the status and the protocol columns. These mean a big deal to me. Why is that? Because status is all about identifying what is going on at layer 1 of the OSI model. That's right, layer 1. Do we have a physical connection with a device at the other end? Are we able to successfully transmit electrical or optical signals with the device at the other end? Is the right cable installed between us and the device at the other end? If all that is true, then we're up at layer 1. If it's not true, then we're down at layer 1. What about protocol? Protocol is all about layer 2 of the OSI model. So what are we referring to when we say layer 2? Well, we're referring to the various encapsulation methods that can be utilized on interfaces at layer 2. So if we have a mismatched encapsulation, well then there's no way we can communicate at layer 2. It means we're not speaking the same language. If we have, for example, with PPP, authentication set up, well, if authentication is not successful, then we can't communicate at layer 2 either. So if we can communicate at layer 2, we're up. If we can't communicate at layer 2, we are down. So in the output here of show IP interface brief, I can see my status, I can see my protocol, so layer 1 and layer 2, but I also have the ability to see my IP addressing that's assigned to my interfaces. So as a result of that, I can really verify here layer 1, layer 2, and layer 3 of the OSI model with the output of show IP interface brief. But I want to take a closer look at my line and my protocol status here. We've said up and down and administratively down so far when discussing our interfaces. So what does administratively down mean if we see it as part of the line status? So if I see administratively down in the output of show IP interface brief, where might we see that? Well, we can see that right now on gigabit Ethernet 0/2. Notice it says administratively down in the output. So what does that mean? It means that we used the shutdown command. That's all that means. We physically shut down the interface. No communication can occur out this interface. We are shut down. Administratively down. So what about down now? Let's see an example of down. Let's go back over here. You'll see serial 0/1/0 is down. Now, why is it down? Well, let's take a look at that. Down means we have a problem at layer 1. That's what it means. So the interface is not shut down. The only time the interface would be shut down is if we saw administratively down. So the interface is enabled, right, with the no shutdown command. But we would see down if I can't talk out this interface at all. Meaning, do we have a physical connection? So if there's no cable connected, then I'd be down. What if we had a transceiver issue? Possibly, we could be down as well. What if one side's powered on, like my router's powered on, but whatever we're connected to is off? Well, can I communicate with that device then? No, so I'm down at layer 1. So down. If I'm down at layer 1, I'm going to be down at layer 2. There's no way you can be down up. right? There's no way you can be down up, because how can we speak at layer 2 if I can't even talk to you or connect to you via layer 1, right? Got to have a connection at layer 1 before we can communicate at layer 2. So down means we have a layer 1 problem. Anything wrong with the physical layer causes us to be down. Now, what about up down? Do we have any interfaces here that are up down? Up down. I do not see any interfaces that are up down here. But what would that imply? Well, if we are up down, I want you to think about a layer 2 problem. Layer 2. So we can successfully see each other across the physical cable. That's why we're up. But we're down because I can't speak the same language as you. So for example, if we had a serial connection between two routers, if one side is using PPP, point-to-point protocol, and the other side is using HDLC, well, those are two completely different layer 2 encapsulation methods. As a result of that, we can't speak with each other. It's like trying to speak English and French, or I speak English and somebody else is trying to speak to me in French and we can't talk. Well, it is what it is, right? Same idea here. So we are down now. We are down at layer 2. So that's the idea behind up, down. And then if we go back, what about up, up? Do we have any interfaces that are up, up? Yeah, we do. Look at all these interfaces that are up, up. What does that mean? That means we're up at layer 1. We're up at layer 2. So all is well. The interface is functioning fine. I can successfully transmit my bits across the link, physical layer, and we're speaking the same language at layer 2.